Now we are going to arrive at the 1.5 degrees C threshold crossing probabilities, exceedance probabilities from another viewpoint. In 2023, there was an El Nino, and during an El Nino, the heat that is being absorbed or taken up by the ocean in the tropical Pacific during normal and La Nina years gets emitted back or thrown back into the atmosphere. So it causes a little warming on a global mean that's measurable, fraction of a degree typically, that adds to global warming. So El Nino is called a mini global warming sometimes. But the warming that actually happened in 2023, which was a record warm year before 2024 took over as even warmer, and we have been looking for reasons why it was much warmer than global warming plus El Nino. And we have invoked wildfire emissions, and also there was underwater volcanic emission, Hunga-Tonga, Hunga-High Pi in the tropical Pacific, which threw up lots of water vapor and sulfur dioxide into the atmosphere. Atmospheric volcanic eruptions typically throw up a lot of ashes and other things like sulfur dioxide, which tend to actually cool the global climate for a few years after the volcanic eruption, if it is strong enough. But this volcano, because it threw up so much water vapor, is argued to be actually causing warming, and the impact is expected to go on for a while. So this paper actually took the emissions estimates and took the projection scenarios, the shared socioeconomic pathways, and computed the probabilities that the emissions or the eruption of the Hunga-Tonga actually changed the probability of the 1.5 degrees C threshold crossing or exceedance. And there is still a debate going on as to whether that really is what happened or what will happen and so on. But nonetheless, we keep tracking how close or how far we are from 1.5 degrees C, even though I keep saying that these are not really scientifically derived targets, but nonetheless, you want to keep the warming to as low a level as possible.